I'll keep looking at my notes because I have a lot of things to remember and I'm getting old. Sorry for that. Let me start by introducing myself. My name is Daniil. Currently, I'm working as a staff QA engineer at Grid Dynamics, doing some full stack testing on pretty complex e-commerce project. But long before I switched to software development, I used to be a QA engineer in oil and gas industry. And obviously, that industry has a very different working practices from software development. So today I'd like to introduce you to a couple of concepts which are pretty popular in hardware industry and not yet widely known in a software development. So let's start. Today we have to discuss 4 purely theoretical concepts and let's say introductions and get a little case study to apply it to a practical task.
What's the name of the presentation?
Okay, let's name the presentation. It's proactive risk assessment using software system theoretical process analysis. And let's start with discussion of a difference between the proactive and reactive approach to software bugs. Both approaches are required, but traditional testing is more focused on reactive approach. And reactive approach is focused on fixing issues after they appear, which can lead to a higher cost and impact user experience. And proactive approach aims to prevent issues from happening in the first time by using structured analysis and risk assessments. And my personal opinion is that modern QA shall shift toward proactive risk management. And while we discuss proactive approach, you might realize that you subconsciously use some of such practices. And the goal is to make them planned and structured. So key differences are that a reactive approach responds to issues after they occur, focuses on debugging and patching, and relies on post-mortem analysis. Proactive approach identifies risks before failures occur, ensures stability before deployment, and focuses on preventing issues through analysis and risk assessment. Well, definition is here. I'll not read it, but I would add that each project has some kind of risk assessment during its planning and execution. And mostly it's done by some experienced senior engineers subconsciously based on their extensive experience of failures. But our goal is to make it structured, planned, and covering as many functional blocks as possible. And it's important because it helps prioritize testing of certain areas, like high-risk areas, and prevents significant business safety and operational impacts. Okay. So you might see a little pretty scheme, like functional scheme of a modern e-commerce project. And if you pay some attention to the tiny lines connecting all the blocks, you might realize that those are interactions between components of the system. And each interaction may fail in a very different ways, leading to failure of complete project. So main idea of risk assessment and process analysis is to switch to system thinking and perceive every system as a list of connections between components, not just components themselves. Okay, risk assessment matrix. It's a concept which was created in an industry like 45 years ago, like, I mean, hardware industry, like real industry. And it was created as a concept to attempt to measure or quantify risks. That's how the risk matrix looks, and it helps QA teams quantify risks based on their severity and likelihood. So on horizontal scale, we have severity, which might be mapped to a normal, like bug severity, from minor to severe, and it's pretty common in QA. What is not common is second dimension, which is probability. I know that some people are writing, let's say, bug reports with probability, but that's not a common practice. And that's the main difference between manifested defect and the risk. So obviously, when we found a bug, we most probably know the probability of such things happen. Okay. And number in a cell is called risk rating. And normally in the beginning of any project, we define like severity levels and probability levels. And we agree, we get on common ground what we consider as a severe project and what defect and what we consider a minor defect or risk. And the same with likelihood. So the idea here is to get on a common ground on what we can tolerate as a risk or as a defect. So in this case, let's say we have everything higher than 15 as, let's say, a red area. So we are not tolerating such things. We might live with everything which is in green, and all the middle, let's call that color yellow. That's a borderline, which we analyze on case-by-case study. Okay. Let's get to a couple of examples to illustrate how does it work. So we have a risk or defect if it's manifested itself on payment gateway downtime. And it has severity of 5 because it leads to a direct revenue loss. And the probability is low because we hope that our payment system uses robust payment infrastructure. And general risk rating is 5/2, 10. We call it medium on our scale. Data privacy leak. Again, severity is very high. It leads to legal implications, trust loss, and so on. But probability is higher because even while we have security measures, still some vulnerabilities may remain. So 5/3, 15, it's high, and such obviously areas must be addressed at the first as a first priority. And any guesses on this one? Okay, there are no wrong answers here, but it's just an example to think. So inventory mismatch in e-commerce. Any ideas? Why high?
Customer doesn't need. It's very serious.
Okay, you might sell things you don't have, which is even worse. Okay, and probability?
I guess depends. If it is a stable company and it never happens, so low probability.
Okay, so it might be low. 5/1, it's 5,
It's
and
5.
we shall not consider it as a serious risk. Most probably that's very rare. Okay. Thank you, by the way. Okay. Okay, System Theoretic Process Analysis. It's a new concept for software industry, but pretty old for other industries. And it was developed as a framework to identify risks before we actually build any product. So it was developed in MIT for safety critical systems like aerospace, automotive, healthcare, and so on. And the idea behind that was that you cannot build enough rockets to find all the bugs. Yeah? So you have to build them better. Okay, so now it's applied in software development and QA as well, due to the fact that modern software systems are very complex and maybe even more complex than, let's say, airplane. It represents proactive approach to system risk assessment. Again, if we have anything which is already built, it's pretty easy to assess risks, but it might be too expensive or some people might get killed. STPA focuses on constraints rather than failures, and we will get to definition of constraint later, but just remember the word, it's kind of rule. And I have to stress that it's just one of the methods to assess risks and not the answer to any question. We have a couple of key definitions to understand STPA. Let's get them one by one, and I'll read it because I had to create them as short as possible. So, hazard is a state of system or a condition that combined with some triggers can lead to an acceptable loss. Constraint is a rule or condition that prevents hazardous states, keeping the system within safe operational boundaries. Failure, it's a case when a system or component doesn't perform as intended, allowing a hazard to manifest. And the last closest to testing is a loss scenario. That's a chain of events or conditions that let a hazard escalate to an acceptable outcome. Might sound strange, but you'll get it later when we get closer to practice. So, key concepts of STPA. First, as I said, we switch to system thinking from like black box, let's say, thinking. We shall not consider just individual components. We shall analyze the whole system as a network of interactions between those components. And failures often don't happen from a faulty component. They happen from unexpected or unsafe interactions between those components. So if nothing happens, no action happens, most probably no bugs are like happening as well. Traditional bug fixing focuses on isolated failures or isolated defects. So we found something, we patch it with a piece of duct tape and go further. STPA emphasizes understanding of the whole system and system-wide hazards. And constraints are especially important because constraints are rule and limits which must be incorporated in any system to prevent it from unsafe behavior. And these constraints are like especially important for QA, yeah, because obviously we have to test them first. Okay, most probably you have some questions or not, but let's keep them for later because after the case study, we'll have a small like Q&A session, some allocated time for that. So let's try to apply what we've learned today to like a practical case study on a piece of e-commerce project. So STPA has 4 steps. First of them is defining purpose of analysis. So the idea here is that we shall define like limits and borders of the system we are working on and losses we are considering. So we obviously cannot analyze the whole world. So we have to limit our analysis to a certain part of the world. Losses to consider. data breach, financial loss, system downtime, and so on. With that in mind, we start with modeling the control structure. Generally, it boils down to a visual representation of system components and interactions between those components, like controlling actions, feedback loops, and so on. On step 3, we identify hazardous control actions, and the idea is that we shall think how the system will behave if those actions execute incorrectly, too early, too late, not executed at all, and so on. And on step 4, we analyze how and why those hazardous control actions may occur. We consider system flaws, human errors, environmental conditions, and so on. Let's proceed to our example. So let's define the system, and the system as a whole is composable e-commerce platform with serverless architecture, and the piece of that system we are working on is the order placement flow. Some main risks, obviously there are a lot of risks associated with order placement, but let's get a couple of examples. We might lose revenue and reputation by some improper interactions with customer. We might oversell things and lost revenue because of that. And we might get unhappy customers, and so on and so on. So we get a list of business losses we shall not tolerate at all. Yeah? That's on the, let's say, project planning stage. And we put them in a table, like an Excel one or piece of paper or whatever. And that alone actually is a pretty good, let's say, mental exercise. Because when you're building system, you shall keep in mind, like Bart Simpson writing on the desk, yeah? I am not selling things I don't have. I don't make my customers angry, and so on and so on. And if you keep thinking of it, it makes you a better tester, like instantly. So then we define the interactions and pieces of system, and it's not about like a technical architectural diagram. Yeah, it's just functional parts. So we have a customer which interacts with a checkout application, which interacts with a payment system, and so on and so on. And that's just a functional representation of physical and informational links between parts of our system. In a normal analysis, we have more of these arrows. So I would say that I would write a control flow, feedback flow, which in this case is a customer inputting some data, that's a control, and receives, let's say, visual confirmation, that's a feedback flow. And sometimes while doing modeling, we realize that we have more like losses and risks than we were initially planning. We're getting to step 5, adding something to the table, and so on and so on. And some people are actually starting over here, but that's not how it's like supposed to be done. Okay, on step 2, we identify hazardous control actions. We think how each of those interactions might be altered or broken, and what action might lead to that change. So in our case, we have like payment gateway confirmed transaction without fraud validation. It might be associated with a loss of customer dissatisfaction or overselling or so on. And let's focus on customer dissatisfaction. We might put order services, processes, duplicated transactions. So we charge our customer twice. Yeah, obviously it leads to a pretty huge amount of dissatisfaction. Okay. On step 4, we identify loss scenarios which might lead to those unsafe actions. And if we focus on duplicate transactions, we might see that API latency causes duplicated requests, for example. So the flow goes like that. We have a business area like customer dissatisfaction. We have some actions which might alter the system interactions to lead to the dissatisfaction. And we have some particular scenarios or on how we can make our customer unhappy in this case. And you might notice that those loss scenarios are pretty close to negative test scenarios. So that's a thing you can actually test. You can measure API latency. You can prevent it from like duplicating requests and so on. That's a particular point of interest for QA. And on the last like step, we put them all in a single table. Like we have losses, HCAs, and lost scenarios in the same table. And you shall understand that each loss, it's a very high level risk. So it's very like a customer dissatisfaction. You cannot actually test or check customer dissatisfaction, but you might prevent your customers from being unhappy and angry at you. So HCAs, that's about changing the system flows and interactions. And scenarios are particular things on like how we might change those interactions, how we might break our system, control and data flows. That's where system analysis ends, and we proceed with the risk assessment itself. Remember the table, yeah? So each loss, HCA and lost scenario is not a bug yet and not a risk yet, because we don't have its severity and probability. So on this step, we define those values and make risks out of, let's say, hazards, which are not manifesting yet. So we take all that stuff from the table and put them in a long list, like it might be a table as well. For each risk, and now it becomes risk, we specified probability, severity, and a short mitigation plan. And that mitigation plan is a thing we might test. And obviously, we prioritize testing of the highest risk areas. So we just sort by priority, which is our risk rating, and start with testing the more important stuff, important for business, not for us. And why do we need it? Just because we are limited, like every project is limited of in terms of capacity, testing capacity, times, budget, and so on. And it's much better to test important things and not test not important things at all than just test everything, but like with a, let's say, shallow testing, not a deep one. And those were two concepts I would like to present today, and they might be applied on a different stage of a single project. So we might use risk assessment matrices for better decision making on a project planning level. Yeah, so we don't know, let's say, what payment system we will be using on the project, but obviously we know that that's a payment system. It has some losses associated with it, and we might start testing even before we start building the project itself. On a test planning stage, we might identify the highest risk areas we would like to focus during our testing. That's pretty obvious. For automated testing, we might incorporate constraints in both production code and our test code. Yeah. Important keynote here, test code is a code as well, so it must be tested as a normal code. And for incident analysis, so for bug investigations, we might use STPA as well, because usually what we get is a bug. And obviously, we might patch the reason, add an if in our like production code and so on, but it's much better to find why is that bug happening. And we might use control diagrams and system analysis for that as well. Okay. So you can scan QR codes. You can get official STPA book. You can get MIT introduction to STPA as a system. It's much, much more complex than I was presenting today, but my main idea was to let you know that such things exist in general. And if you'd like to learn it, you can learn it on yourself or get a course from someone else. Okay, any questions?
Don't be shy. Yeah. Thank
Mhm.
Hi, everyone. Thank you for presentation. It was really good. I have a question. So if I'm not wrong, STPA should be used before the project even starts. Are there any techniques in the STPA handbook that can be used in already running project? Maybe it's like in the mid. Yeah.
Obviously, on the last slide, I actually showed that it might be used on like different stages of the project development and planning. Obviously, if you have already built system, you might model it as well. You just get like a big list of paper and start modeling systems and subsystems and their interactions. So, and you see, the idea here is that by applying some risk analysis and risk assessment, you might find bugs or prevent them from happening before they manifest themselves. That's the idea. It doesn't mean you shall not have any project yet. You can apply it to existing project as well. Just start by modeling it, get like HCAs, like hazardous control actions, get lost scenarios and test them all. It's not limited to the project planning itself.
So you like control the flow.
You can ask in Russian.
То есть ты как бы, не знаю, стреляешь и не оставляешь стрелу лететь там в цель. Ты как ракета, которую ты управляешь в полете. То есть ты можешь, например, ты приходишь на проект, который уже ранится. Ты видишь, что уже есть какой-то анализ был произведен, ты знакомишься с ним, есть какие-то архитектуры, диаграммы и так далее. Есть ли смысл в том, чтобы, то есть выяснив и уже уложив в голову модель проекта, визуализировав даже, есть ли смысл с нуля строить подробный анализ, вот выстраивая риски и probabilities этих рисков?
Ну, во-первых, это зависит от проекта, да.
Не везде есть такая возможность. То есть
если есть, я считаю, да. Вообще, когда я начинаю работать над новой функциональностью, я для себя на бумажке обычно это делаю всегда. Это может быть не так прям детально, как вот я сейчас говорил, но я это все равно делаю. Я рисую, например, control flows, я рисую data flows и выясняю, где там эти критические точки находятся. Да? Это может быть не очень документированный анализ, я там не добавляю таблицу в Confluence, но я сейчас сравню примерно, да, вот это сравнение, как ты можешь просто гулять по городу, как бы, да, хаотично и надеяться, что ты найдешь пивную, да, а можешь составить карту всех пивных и идти куда ты хочешь. Вот здесь то же самое. Отчасти это как бы техника тест-дизайна в том числе. То есть ты выясняешь точки с самыми большими рисками и фокусируешься на них. И обычно там ты что-нибудь находишь. То есть да, это имеет смысл и на существующем проекте тоже.
Спасибо.
Спасибо. Я могу тоже добавить из личного опыта тоже. Даже на уже старом, да, maintenance project иногда есть такие моменты, что можно, в принципе, сделать этот анализ, и бывают случаи, которые, ну, упускаются, BA упускает. Вот это как бы, у меня был кейс такой, как бы, это мне помогло, и правда, после этого, конечно, BA начинает там писать в тикетах business contact is not for QA, там строго acceptance criteria, да. Но стоит это тоже употреблять даже в существующем проекте, да, конечно. Кто-то еще? Anyone else with some questions to Daniel? Okay. Yeah, sure, why not? Coming.
Да, извините, снова на русском буду.
Без проблем.
Да, вопрос, наверное, такой. Мы пробовали применять такую фишку у нас в компании. Вот. Единственная проблема, ну, у нас два момента есть. ПМы могут сказать о том, что не обращайте внимания, что эти риски, которые вы посчитали, это неправильные риски, то есть у нас другое мнение. И с BA тоже бывают конфликты, потому что у нас бывает, что мы видим какие-то подводные камни, мы также анализируем и говорим, предоставьте нам более подробный бизнес-сценарий, потому что здесь явно есть какие-то гэпы, которых мы не можем сейчас, ну вот, потерянные сценарии или потерянные requirements. На что BA говорит о том, что типа у нас уже нет времени обращаться к клиенту, потому что это своего рода какие-то... Ну, то есть в этом случае я всегда рекомендую shift-left approach, чтобы до того, как принимать какие-то решения, все-таки были какие-то консультации с девами и с QA перед тем, как с клиентом общаться. Вот. Но иногда бывают такие кейсы. Как бы вы рекомендовали, как стоит нам в таких моментах?
Ну,
поступать?
во-первых, да, тут надо как бы подчеркнуть, что это вопрос человеческих отношений, а не системы в целом, да, то есть как бы система как методология ничего о ваших проблемах не знает. Как рекомендовать? Ну, работать с людьми, то есть, естественно, чем раньше вообще QA... Давайте вот так, давайте разделим, да, есть тестировщики, которые приходят на условно готовое, да, и его там тестируют, да, и есть quality engineering, который в теории должен начинаться еще там на этапе планирования проекта. Ну, то есть вы все правильно говорите, конечно, надо это как можно раньше начинать, как можно раньше эти риски все обозначать, доносить. Ну и вообще, в принципе, наверное, работа QA не самая просто приятная, да, надо ходить, задалбывать всех, рассказывать им, что вот мы видим здесь потенциальные проблемы, да, как бы. Но это все упирается в человеческие отношения. В какой-то момент, наверное, вы докажете свою состоятельность, скажем так, да, в том числе и BA, и они просто будут больше к вам прислушиваться.
I also want to add here because indeed being a QA sometimes is really tough and painful, almost crying. But I used to also have a project like with almost 3 years, and such situation like you described. How we handle these situations at Grid Dynamics projects, most of them, we actually do really implement the agile things like having those sessions, retrospective sessions, when you need to be brave, you need to speak up. And we also have a lot of one-to-ones, constantly planned and periodal with our PMs, DMs, and we can tell them how we see the situation and how they should address sometimes, being like a referee, let's say, because they're responsible how it will work after, and it's also depending of the quality of the people you work with, for sure, how professional they are to accept your opinion as a QA, because you also have brain and you also can analyze, and sometimes it's a better analysis even provided by someone else before. Yeah, thank you.
Yeah, but you see, a retro is a reactive approach, yeah? And if you see risks
Unfortunately.
beforehand, yeah, you're trying to prevent them from happening. So yeah, you just have to work on, let's say, your internal reputation. Yeah? Internal, I mean, in your project.
It's reactive, but as we still have like cycles, it's reactive for the current cycle, but might be proactive for the next ones. Why not?
Yeah, that makes sense.
Anyone else? Well,
No?
thank you. In this case, that was Daniil. Really calm and fearless, I would say. Thank you very much. That was an analytical topic that we triggered. Thank you.